measure the resistivity of nichrome. So we get nichrome, okay, so there's our nichrome, so nickel chrome, so it's a resistance wire, okay. I've got a sample of it here, you can see it, okay, and I have it connected to two crocodile clips, and I have the crocodile clips then, I have it connected in the circuit to the multimeter, okay, so the multimeter again, sorry, let's start from the start, okay, so always to common, and look at the ohm, you see the ohm symbol here, okay, so to the ohms. You then turn this around to ohms, which is here, and you start at 200, which means it'll read the resistance up to 200. Whenever you're getting the symbol for ohm for resistance wrong, remember that's the symbol for resistance, ohm, okay, not R. Right, okay, now what I've done is I've set this up, the length of this, okay, so I need to do two things. I need to measure the length, and I need to measure the resistance. So the length I have set up here that it is, okay, you try to remove any kinks, and you straighten out the wire as best you can. So I've done that, and basically I have the wire there, and it is 50 centimeters long. So 50 centimeters, so take note of that, okay, and you're changing that obviously to meters. Okay, second thing you're doing is you're taking note of the resistance of the wire. Okay, so there it is. All right, so you now have the resistance and you have the length of the wire we're using. So all we need to find now is the cross-sectional area, and to do that we need the diameter. We need to get the diameter, then the radius, then the area. So the diameter, radius we have the diameter, area pi r squared. Okay, so we're using a micrometer screw gauge, I apologize. Okay, so this measures, you can see the gap here, it measures diameters, okay, and it has what's called a vernier calipers on it. Okay, it's very straightforward. So if you see there, okay, notice it's pretty good, okay. You can see the zero there is at the zero, it's pretty much across at the zero here. Now there can be a zero error on these, but in this case we're going to ignore that, it's very close, okay. So as I open that up, okay, it gives me the diameter, the gap here, which would be the diameter of the wire. And the wire should be a uniform wire, in that it should be the same everywhere. But to check that, we get the resistance 5 times. Now you don't get, or so you get the diameter 5 times. We don't get the diameter 5 times in the same place. We get it 5 times in different places. Okay, so you just put it in, okay, between the jaws. So place the wire between the jaws, close it, don't over tighten, okay, and then give it 2 further clicks here. Okay, the clicks aren't working, we pretend we heard the clicks. Okay, and you look here then, and we there now have a reading of 31. Okay, so it's 30, and it's up 1 if you're looking at the horizontal line as the 0 line. So 31, ignore the zeros coming out here, so 31. Now that's not 31, that's 0.31 of a millimeter. That is 0.31 of a millimeter. Okay, so 0.31, so you're taking note of that. And then we're going to move along to another part of the wire. Now let's be very clear on this, it's not getting the resistance to the same part. We want to make sure the wire is the same resistance everywhere. So I'm going to do the same thing, tighten it up, a few clicks, there should be 2 clicks there, okay, and we look at it and it's 31 again, quite remarkable. Okay, and we go again, 2 clicks, okay, and 31 again. We'll do one more. Now if these weren't equal, you'd have to be getting the average of them, okay, but okay, remember the 2 clicks, okay, and there we go, it's 31 again. So the 4 times you've got the diameter, you've got 0.31 of a millimeter each time. So you've got the resistance, you've got the length, and you've got the diameter. You've confirmed that it's uniform diameter, and you're ready to go. Okay, so it's just a case now here of filling in the formula in this case. Thank you.